So as a review, you've got the force times time, which is called impulse, is equal to the change in mv, and mv is called momentum. So if I want to change the momentum of an object, I can't change the mass of this car, but if I push the car longer, let's say I exert a force on it, the longer I can exert the force, the greater the change in momentum. So think of pushing the merry-go-round, okay? You're pushing the merry-go-round. You want to push it as long as you can, as hard as you can to get it to accelerate, okay? Because you're not going to change the mass of the merry-go-round, but you can change the velocity. So if you just give it a shove, boom, okay, it might go around a little, but if you give it a shove and continue shoving while you're running, you can get it going a lot. And that's the idea of an impulse. It changes momentum. So this should be review. If you want to follow through, then you can start an object that is at rest into motion. If you want it to go as much as possible, then you want to hit it as hard as you can, that's your force, as long as you can, that's your follow through. Okay? If you want to strike when you're playing bowling, you want the biggest ball you can move with your arm, and you want that changed. You're pushing that ball as long as you can before it leaves your hand. Just like trying to accelerate an object from rest up to a speed, I can decelerate an object and it changes the force for a second. For instance, if you want to catch a ball, you don't just hold your arms outright and then grab the ball, because that full force of that ball is now into your arm and it can hurt you. So you would step back as you're catching a ball, or you pull your arm back as you catch the ball, because you want to catch it over the longest period of time that you can. Just like you wanted to launch it over the longest period of time. So a football player that's throwing a pass wants to keep his fingers on the ball as long as he can while his arm is moving. Your arm is accelerating that ball, and while you're touching it with your hand, you're putting a force on it. As soon as it leaves your hand, you're no longer putting a force. So the longer it can be in your hand while you're accelerating your arm, the faster the ball will move. Well, exactly the same. If you're catching a football, okay, let's say you catch it not on your chest, but you catch it in your arms, you grab forward and then you pull back so that you're catching it as long as you can. So if I want the force to be expanded, if you want the force to be bigger, you exert the force over a time, because impulse is a formula of product. It is time times force. Okay, so if you don't want the force of that to hurt you, say catching a baseball, you want to catch it as long as you can. So if you want to jump off the bed, you want to bend your legs so that you're hitting the ground as long as you can. So as your legs are contracting, it will absorb that force, will absorb the shock. If you want it to hope that the glass doesn't break, dropping it on a pillow will make that impact longer. So the impact longer will reduce that velocity, which means you're changing momentum. You're changing it from fast to zero, and the longer you can do it, the greater the change in momentum will be. Here's a cool example. You've got on one side momentum. Momentum is mass times velocity. So here's a truck. It's got a great mass, but it also has a fast velocity. So let's say that's a high momentum. It hits the hay. How long is it before it stops? Okay, as it hits the hay, it's moving through the hay, but the hay is slowing it down. So the time is great, and that means that the force doesn't have to be as great. The force on that truck is not great. It was kind of a wreck, but it didn't destroy the truck. If you have a very short time, say the bottom one, where the truck is hitting a brick wall, it stops in a very short time, so you're stopping it in a short time, then you have to have a huge force to stop that momentum, all right? So let's say that you're in an amusement park and you want one of these rides that go from 0 to 60 in 1 second, all right? If you want to change the momentum of that car that you're riding from 0, which is no momentum at all, to a very high momentum, which is whatever you weigh times its speed, then you need to have a huge force, a huge launching force, okay? Otherwise, you can still go to that speed in a long time and not need as much force. My car can go from 0 to 60, okay? It may not go as fast as your car. Your car could exert a huge force on it in a short time and change its momentum. My car can exert a small force over a long time and change the momentum exactly the same. My car costs less because the longer it takes to change that momentum, people are willing to pay less for it. So if someone's going to hit you in a boxing match, you don't put your head into it, you put your head away from it. As you move your head away from it, you're taking that impact longer, which as you increase the time, you decrease the force, and that force doesn't hurt you as much. If you are shortening the time by jumping into the punch, well, that's stupid because you are shortening the time, you're increasing the force, and the impact on your face is worse. If you've ever tried to break boards or blocks in a karate class, usually you do not ask the beginner karate kids to do this, okay? Because the trick is to bring your arm down with as much speed as you can, but impact the blocks or the boards as short a time as you can. All right? The longer that your hand is pressing on the blocks, the less force will happen. The shorter the time, the greater the force. So if your arm has momentum because it has mass and speed, okay, your arm weighs something and it's going at a certain speed. So if you crash it down really fast and then impact the blocks very, very short, then all of that momentum is converted into force, and that force may be enough to break the blocks. The longer you hit it, okay, the longer your hit actually takes, the less force is going into that board, and all you're going to get is a bruise. The last I want to mention is bouncing, all right? So this is a great example. I'm going to just use this one instead of mine. If a flower pot falls off of the shelf and you catch it, all right? Normally you have your hands up and then you'll drop your hands lower and slow that pot down so that its change in momentum takes time. The longer the time that that you catch it, the shorter the force is, and you probably won't break it, okay? Well, if you want to send it back, so it's falling onto your hands, now you want to send it back, it's going to take all the force that you have to change its momentum down to 0, and then you have to change the direction and then speed it up again. So if something bounces, it has to have more impulse than if it just hits. So if a flower pot falls off the shelf and hits you in the head, there's a certain amount of damage. But if it bounces off of your head, then what's happened is you've changed its velocity once by stopping at 0, and now changed it twice by accelerating it back up into the air. That's more damage on your head. If you hit a lamppost in the parking lot and your car comes to a stop, okay, that's a certain amount of damage done to your car by the pole. But if you bounce it off of it, come forward and then bounce off of it, way more damage has done because you've had to stop it to 0 and then accelerate it in the other direction. That car was going forward at a certain speed, it stops down to 0 and then bounces and comes back. That means it had to be accelerated backwards. That takes way more force, okay? So bouncing, generally, there's a greater impulse to bounce an object than to simply stop an object. Here's the last example. A Pelton wheel is a mining wheel. So when the water hits it, it doesn't just stop it, but it actually turns it in a circle and makes it go backwards and essentially bounces the water. And when you bounce the water off of the wheel, you can turn a wheel with less rush of water. So let's say you don't have a huge waterfall, but you have more of a trickle. If you can send that water out, you can move the wheel around even with less force, because you're getting more out of a bounce than you are out of a stop.